Till now whatever we discussed about the extensions and all, elongations and then compressions and all, we have discussed about the massless bodies. Now here under its own weight nothing but, actually yesterday, otherwise day before yesterday, we have taken a string, for that we have hanged some weight of mg we have hanged, and then we got that Young's modulus. Do you remember the formula? F is y is equals to, what is the formula we got? mg L divided by pi r square into delta L. This is the Young's modulus we got whenever I have taken a string, and then for that I am just hanging a mass of m. At that time that was the Young's modulus we got. Now what I am doing nothing but, I am not hanging any masses here. I am taking only the massive string here. This massive string of mass how much nothing but m, and the length is how much nothing but, we will take it as small l. Length is L and the Young's modulus is y. You have to find out the elongation. That elongation here is due to its own weight. For example, you are hanging some wire for 1 month, means it will elongate compulsory. Why? Because on that mg is keep on acting only. So that due to the own weight, the elongation produced here is how much nothing but, that is E. So from that you have to find out that elongation value. What is the Young's modulus formula for us? Y is equals to, what is the formula? FL divided by A into E. Now you have to find out the E only. E is equals to what I can write? FL by AY. Now if they have not even given the mass, you have to find out in terms of density. Even then there is no problem in that. But here they said that massive string nothing but where the force will act? Exactly at the center of gravity, under its own weight. Where the weight will act? Weight will act at the center of gravity only. So that the center of gravity is there here. Here mg is acting, and the area of cross section is, we can take it as A, otherwise radius is R also you can consider. Now mg is acting, F is mg, length is at what length it is acting mg? Mg is acting at what length? L by 2 length. So that L by 2 divided by area into the Young's modulus y. This is the elongation we will get. Then elongation E is equals to elongation E is equals to, I can write it as mg L by 2 into A into y. Whenever they have given the mass, happily we can substitute and then we can get the answer. If mass is not given, at that time what you have to do? If mass is not given means, in the place of mass what I can write? Rho into volume. Rho into volume formula is what? Area into length into G into L divided by 2A into Y. Area gets cancelled. What I can get here? Half into rho G L square by Y. That is the elongation we will get in terms of density. So here mainly you have to observe is, so many people will do only one mistake, that is they will take directly mg L only, this one L only they will take. Why? Because you will think that mass will, their weight will act here. But own weight nothing but, whenever you consider this as a massive string. Till yesterday everything we were discussing about the massless string only, this is a massive string, otherwise massive wire. That wire is having some mass means under its own weight, where weight will act means exactly at the center of gravity it will act. So at the center of gravity the weight is acting, that is a force we have considered here mg. At what distance it is acting it as? L by 2 distance, at exactly L by 2 distance. So that y is equals to, our formula is FL by AE. From that elongation only you have to find out E is equals to FL by AY. So F is equals to what here? Force is, which force is acting? mg. At what length it is acting exactly? L by 2 length. So that L by 2, that divided by area of cross section is A I considered, that divided by the Young's modulus of the material whichever we have considered. Then after that we got the formula as mgl by 2ay. Then after that, in the place of mass what I can substitute? Nothing but density into volume. So that density into volume formula is what? Area into length. Area cancels, then rho L square G by 2y will be there. That is what I have written here. E is equals to half into rho G L square by y. Clear, right? Let's copy that. Elongation due to one weight. And also you write one line in that. As the string is massive, the weight will act at the as the string is massive, the weight will act at the center of gravity. weight will act at the center of gravity, that is at L by 2. Copy that. Here, next one more thing is, next one you write as force constant of material, force constant of metallic wires, force constant of metallic wire or rod. Force constant you have to see, this is like same like the force constant of spring only. There what will get K only, right? What is the formula? F is equals to Kx, K is equals to F by X we will take. Here also the same thing only, here also we will take it as a K only, but that is a spring constant, this one is a force constant, both are same. I said while starting the topic only, you have to relate everything with the springs only. So here again this one, whenever I apply more force, then what happens? I can get more elongation obviously. So that F is equals to what I can write? F is directly proportional to the X. X is the elongation here. If I apply more force, I will get more elongation obviously. So the F is directly proportional to X. Now this F is equals to what I can write? Nothing but Kx. This K is the force constant here. Force constant. Now I want to get that K in terms of the Young's modulus. So K is equals to what I can get here? F by X. What is the Young's modulus for us? Y is equals to FL divided by A into elongation is how much here? X now we are taking it as. Elongation is E generally, otherwise it is X, anything it might be. Now in the place of F, what I can write? F is equals to YAX by L. So YAX divided by L, that whole divided by X, then X gets cancelled here. What will get here? YA by L. This is the force constant K. K is equals to YA by L. Listen again. So here on the rod, on the uniform rod, if I consider of length L, then what I am doing nothing but I am applying force here. Whenever I apply some force, then little elongation will be there. Whenever I apply more force at that time, more elongation will be there. So the force is directly proportional to the X only. There is a more force, there is a more elongation. So that F is directly proportional to X. Now that proportionality removed by a constant K. Just forget about the spring constant. This is another force constant. Anything you can take even C also, but C will come in the torsional rigidity again. So that only I did not take it as a C. Anything you can consider. So the F is equals to K into X. Then this K is equals to what I can write? F by X. This elongation is there in case of which one? Which materials? Strings only, right? Rods only, right? In rods what will be there? Linear rods will be there, linear bodies. Which modulus will be there? Young's modulus will be there. So that Young's modulus is equals to FL by A into E. But here elongation how much I said? X is the elongation. So FL by A into X. So that F is equals to YAX by L. So from that again I substitute the F value here, YAX by L, XX got cancelled. K is equals to how much we got? YA by L. This is the force constant of a string. Force constant of a rod, otherwise anything, string or anything you can take, metallic wire or anything. So that is about the force constant. Now whenever you come to the potential energy stored in the wire, otherwise whenever you are stretching, what work you are doing? The work done in the work energy theorem only I said that the work done in stretching the wire will be stored as what? Potential energy in the spring. In the spring concept I said that whenever you are doing the work to what is that, we are extending the spring, nothing but that work will be stored as what? Elastic spring potential energy. Do you remember that concept? The work done in stretching the string will be the spring will be stored as what? Elastic spring potential energy. In the same way, the work done in stretching the string will be stored as which energy? Nothing but this potential energy in the wire it will be stored as. So can I say that work done is equals to potential energy? W is equals to what is the formula for us? F into X. Energy also is equals to what is the formula? F into X only. So that work done in stretching the spring will be stored as the elastic spring potential energy. The work done in stretching the wire stored as a potential energy. That's it. So that what I can write, nothing but, do you remember the formula of U? What is the formula? U is equals to half into K into X square. U is equals to half into K into X square. Do you remember this formula at least? You are there at least while teaching this chapter? Yes sir. No, I am thinking that I am teaching some new concept only. U is equals to half Kx square, you know, everybody know that. So U is equals to half K into X square. In the case of spring, that is a spring constant. In the case of wire, that will be the force constant you have to take. So that half into K value is how much we got that as? Ya by L into X square. That is a U. U is equals to half Ya by L into, in the place of X again I don't want X value. Why? Because if I don't know the elongation, at that time what we can do, nothing but, here what we are having, Y is equals to what is the formula? FL by A into X. X is equals to what I can write? FL by A into Y. So that FL divided by A into Y whole square I can substitute here. So this half into Ya by L, again and again same story only. What I can write here? F square, L square, A square, Y square. Then what I can cancel here? Ya cancel, L cancel. Then what is remaining here? Half into F square, L divided by A into Y. Now I want to take this in terms of very shortcut formulas like in stress and then strain. For that purpose what I will do, nothing but, here I will just multiply with A and then divide with A. What is the reason? I want to get the stress, means stress nothing but what is the formula? Force by area. Already I am having two forces here, but I am having only this one area here. For that I am just multiplying and then dividing with area. Then what I can write here, this one as half into F square by A square. Then what is remaining? LA by Y. F square, A square, nothing, F by A nothing but what? Stress. So that half into stress square divided by Y. Can I say this is a volume? Area into length is what? Volume. This is the potential energy or work done. This is the actual formula. Actually this one is the actual formula, work done or potential energy. If whenever they have given the extension, whenever they have given the elongation. Otherwise if they give the Young's modulus and then only stress, at that time we can use U is equals to half into stress square by Y into volume. So here one more concept will be there, that is called as the energy density. Mass density nothing but what is the formula? Mass by volume. Energy density nothing but energy by volume, that's it. So energy density, this same concept you will get in the capacitance also. So that is here energy density. Energy density nothing but what you have to take? The potential energy divided by volume. So that energy is, what is the formula for us? Already half into stress square divided by Y into volume whole divided by volume. Volume gets cancelled here. Then what is remaining? Half into stress square divided by Y. Now I want to get the strain also. What to do? I want to get the strain also. What is the Young's modulus formula? Can I write it as stress by strain? Can I write it as stress by strain? Then I want to get the strain, nothing but strain is equals to what I can write? Stress by Young's modulus. Stress by Y. So that here clearly half into, in two stresses I will take only one stress and then stress divided by Y. What is the stress by Y means? Strain. So that half into stress into strain. This is the energy density. energy density is equals to half into stress into strain, otherwise half into stress square by y also. Whenever you multiply with volume, then what will you get? Whenever you multiply with volume for this one, what will you get? Potential energy or work done we will get. Clear? So listen again. This one you understand, right? Force constant K. So exactly whenever you are applying the force, whenever you apply more force, at that time more extension will be there. So that I can say it as F is directly proportional to X. The proportionality is removed by a constant, we have taken it as a K. So K is equals to F by X. I don't know the force, I know the Young's modulus of the wire. So for that, Y is equals to, what is the formula for us? FL by AE, then F is equals to YAX by L. Elongation is E there, and then elongation here is how much I consider? X. So in the place of F, I can substitute it as YAX by L, then K is equals to how much you are getting? YA by L. This is the force constant we got. After that, the potential energy stored in the string or wire, otherwise work done in stretching the wire. You have to find out, means the work done in stretching the spring is known as what? It will be stored as what? Elastic spring potential energy. In the same way, work done in stretching the wire will be stored as the elastic potential energy in the wire. So elastic potential energy, generally what is the formula for us? U is equals to half kx square. Here K is what? Force constant. K is equals to, what is the formula we got? YA by L into x square. Whenever they have given the elongation, at that time we can apply this one. There is no doubt in that. Whenever they have not given the elongation, they have given the stress directly. At that time what you have to do? Nothing but in the place of x, again and again we are doing that only. Somehow we are getting the answer, that's it. We are taking, always you have to take the Young's modulus only. So Young's modulus is equals to, what is the formula we got? FL by A into x, then x is equals to FL by AY. That is what I have substituted here, cancelled everything, and then remaining with this value F square L by AY into half. Now I want to get the answer in terms of stress. For that purpose what I can do? Force by area is equals to what? Stress only. So that here I am multiplying with area and then dividing with area. Why I want to get the F square by A square here. F square by A square, nothing but what I can write that as? Stress square into whatever is remaining I am writing as it is. L into A, nothing but what? Length into area, nothing but volume. F by A, nothing but what? Stress. Squares are there, so that stress square, Y is remaining. That is about the potential energy stored or work done in stretching the wire. Then from that I want to get the energy density. Potential energy density means energy density formula. Mass density nothing but mass by volume will get. Energy density nothing but energy by volume. Anything is same only. So energy by volume nothing but U divided by V I have taken. U value I have substituted and then V value. V gets cancelled here. Then remaining with half into stress square by Y. This is the energy density. Energy density, whenever they have given the Young's modulus, at that time we can apply this formula. Whenever they have not given the Young's modulus, they have given the delta L by L and also stress they have given. At that time, in the place of stress by Y, what I can substitute? Nothing but I can substitute the strain. So that only our formula will be half into stress into strain. If I do into volume, what will I get here? If I get into volume, here the energy density nothing but what is the formula? U by V, that is half into stress into strain. U is equals to what we can get? Half into stress into strain into volume only, right? So that is what we will get. Clear? Copy that. Have you finished that one? Force constant? That one you copy first, later on I will tell the notes. అక్కడ నుంచి లేకు అక్కడికి వెళ్ళి బ్యాక్ బెంచ్ వెళ్ళి అయితే ఇక్కడికి రా ఫస్ట్ బెంచ్కి రా కనబడదు మళ్ళీ అక్కడ ప్రజ్వల్ విల్ కవర్ ఎంటైర్ బోర్డు ಕುಡೀರಿ ಬೇಡ Finish the force constant. Then write that elastic potential energy stored in the wire or work done in stretching. Work done in stretching. The work done in stretching the wire, the work done in stretching the wire will be stored as work done in stretching the wire will be stored as elastic potential energy, elastic potential energy. Copy everything, potential energy and then energy density, everything you copy. Finished, huh? Let a problem. Calculate the work done in stretching a steel wire. Calculate the work done in stretching a steel wire of Young's modulus 2 into 10 power 11 Newton per meter square, length 200 centimeters, and the area of cross section 0.06 centimeter square. Area of cross section 0.06 centimeter square. Slowly by applying a load of 40 kg without elastic limit without the elastic limit being reached. Calculate the work done in stretching a steel wire of Young's modulus 2 into 10 power 11 Newton per meter square, length of 200 centimeters, and then area of cross section is 0.06. Slowly by applying a load of 40 kg without elastic limit being reached. Next problem. A wire of 1 meter long, and 0.3 millimeters in diameter is stretched by a force of 100 newtons. Full stop. If extension in the wire is 0.3 millimeters, calculate the potential energy stored in the wire. And that one more question. Find the work done in stretching the wire. Of cross section 1 millimeter square. And length 2 meters. Cross section 1 millimeter square and length 2 meters through 0.1 mm. Full stop. Young's modulus for the material of the wire is 2 into 10 power 11 Newton per meter square. Solve all the 3 problems. Observe video.